Welcome. Today we'll learn about polynomials and identify which of the given expressions is not a polynomial. Let's look at our options. Before we evaluate each option, let's review what makes an expression a polynomial. A polynomial is an expression that consists of variables and coefficients, where the variables can only have whole number exponents and we can only use addition, subtraction, and multiplication between terms. Let's examine each option one by one. First, let's look at option A. 1 over x to the fourth power. This is not a polynomial because it involves division by a variable. It's actually a rational expression. When we divide by a variable, we get negative exponents, which are not allowed in polynomials. Next, let's look at option B, the square root of x to the fourth power. This can be simplified to x squared. After simplification, this is actually a polynomial because it only has whole number exponents and uses allowed operations. For option C, 2/3 over y plus x. This expression contains division by the variable y, which means it's not a polynomial. Just like option A, this would give us a negative exponent for y. Finally, let's look at option D, x y cubed. This is a polynomial because it only uses multiplication and whole number exponents. When we expand it out, we get x cubed times y cubed, which is still a polynomial. Let's summarize our findings. Options A and C are not polynomials because they involve division by variables. Option B, while containing a square root, simplifies to a polynomial. Option D is a straightforward polynomial. Therefore, both options A and C are not polynomials, but since we need to choose just one answer, we can pick either one as our answer. Remember, to identify polynomials, always check for whole number exponents only, no division by variables, and no roots that can't be simplified to whole numbers. Thank you for watching. Let's solve this algebraic expression step by step. We have the expression AB minus BC plus BC minus CA plus negative AB plus CA. Let's simplify this expression by grouping like terms. First, let's rewrite the expression by removing the parentheses. Since there are no negative signs in front of any parentheses, we can simply write all terms in sequence. Now let's group like terms. We have terms, BC terms, and CA terms. Let's combine like terms. Notice that for each type of term, we have an equal number of positive and negative values. Therefore, when we combine all terms, we get 0. This happened because each term had an equal and opposite term, leading to cancellation. Let's solve a problem about calculating discount percentage. An item marked at 840 rupees is sold for 714 rupees. We need to find the discount percentage from these options: 10%, 15%, 20%, or 25%. Let's understand how to calculate the discount percentage. When an item is marked at a certain price, that's called the marked price or the list price. And when it's sold at a lower price, that's called the selling price. The difference between these two prices is the discount amount. Let's calculate the discount amount. The marked price is 840 rupees minus the selling price of 714 rupees, which gives us a discount of 126 rupees. Now, to find the discount percentage, we need to divide the discount amount by the marked price and multiply by 100. This gives us the percentage of the original price that was taken off as a discount. Let's plug in our numbers. We'll take our discount of 126 rupees, divide it by the marked price of 840 rupees, and multiply by 100. 126 divided by 840 equals 0.15. And when we multiply that by 100, we get 15%. Looking back at our options, we can see that 15% was option B, which is our correct answer. We can verify this by calculating 15% of 840 rupees, which would give us our discount amount of 126 rupees. So, when an item marked at 840 rupees is sold for 714 rupees, the discount is 126 rupees, which represents a 15% discount from the original marked price. Let's solve this algebraic expression step by step. We need to find the value of the expression 2 minus b times negative 3 minus 5 when it equals 0 and b equals 1. Let's break this down into steps. First, let's identify the parts of our expression. We have two binomials being multiplied together. The first binomial is 2 minus b, and the second binomial is negative 3 minus 5. Now, let's substitute the values we're given. When a equals 0 and b equals 1, let's see what happens to our first binomial. In the first binomial, 2 times 0 minus 1 gives us negative 1. In the second binomial, negative 3 times 0 minus 5 gives us negative 5. Now, we can multiply these numbers together. Remember, when we multiply two negative numbers, the result is positive. So, negative 1 times negative 5 equals positive 5. Let's look at our options. The choices are A, 3, B, 2, C, 5, or D, negative 5. Since our answer is 5, the correct option is C. Let's review the key steps we took to solve this problem. First, we identified our expression as a product of two binomials. Then we substituted A equals 0 and B equals 1 into both binomials. Next, we simplified each binomial separately. Finally, we multiplied the resulting numbers together to get our answer of 5. Remember, when solving these types of problems, it's important to take it step by step, carefully substitute the given values, and pay attention to the signs when multiplying negative numbers. Today we'll solve a problem involving the multiplication of algebraic expressions. We need to find the product of the expression 1 plus x times 1 minus x times 1 plus x squared. Let's solve this step by step. We need to choose from these options. A, 1 plus x to the fourth, B, x to the fourth minus 1, C, negative 1 minus x to the fourth, or D, 1 minus x to the fourth. Let's break this down into smaller steps. First, let's multiply 1 plus x times 1 minus x. This is a difference of squares pattern. Remember, when we multiply the sum and difference of the same terms, we get the difference of their squares. So, 1 plus x times 1 minus x equals 1 squared minus x squared, which simplifies to 1 minus x squared. Now we have 1 minus x squared times 1 plus x squared. Look familiar? This is another difference of squares pattern. When we distribute these terms, we get 1 squared minus x to the fourth power. Let's verify this step by step using the FOIL method to make sure our pattern recognition was correct. First, let's multiply 1 plus x and 1 minus x. First terms, 1 times 1 is 1 outer terms. 1 times negative x is negative x inner terms. X times 1 is x last terms. X times negative x is negative x squared. Adding these together, 1 minus x squared. Therefore, looking at our options, we can see that the correct answer is D, 1 minus x to the fourth. This problem demonstrates the power of recognizing patterns in algebra, particularly the difference of squares pattern. When we see expressions in the form of a plus b times a minus b, we can quickly identify that the result will be a squared minus b squared. Using this pattern recognition can save us time compared to multiplying out all terms using the FOIL method. Let's analyze this assertion and reason problem step by step. First, let's look at what we're given. The assertion states that the numerical factor of the term is called coefficient, and the reason given is that the value of x squared plus 6x plus 9 when x equals 2 is 35. Let's first examine the assertion. A coefficient is indeed the numerical factor of a term. For example, in the expression 6x, 6 is the coefficient of x. In 2x squared, 2 is the coefficient of x squared. And if we have just x, the coefficient is understood to be 1. Now, let's examine the reason by evaluating the expression when x equals 2. We have x squared plus 6x plus 9, and we'll substitute x equals 2 everywhere. Let's solve this step by step. First, 2 squared is 4. Then 6 times 2 is 12. So we have 4 plus 12 plus 9. Adding these numbers, 4 plus 12 is 16, plus 9 equals 25. Now we can analyze both parts. The assertion is true because it correctly defines what a coefficient is. However, the reason is false because when we substitute x equals 2 into the expression, we get 25, not 35. Therefore, while the assertion is correct in its definition of a coefficient, the reason is incorrect in its calculation. This makes this an example where the assertion is true, but the reason is false. Remember, when evaluating assertion and reason questions, we must carefully check both parts independently, as one can be true while the other is false. Question about ratios and percentages. We'll evaluate both the assertion and the reason separately to determine the correct answer. Let's first look at the assertion. The quantities compared by ratio must have the same unit. Let's understand this with some examples. For example, we can compare 5 meters to 10 meters, giving us a ratio of 1 to 2. However, we cannot compare 5 meters to 10 seconds as these quantities have different units. Therefore, this assertion is true. Now, let's examine the reason. 30% more than 400 is 520. Let's verify this calculation. Let's calculate step by step. First, 30% of 400 is 0.3 times 400, which equals 120. Then we add this to the original 400, giving us 520. Therefore, the reason is also true. Now, let's evaluate the relationship between the assertion and reason. Both the assertion and reason are true. However, the reason about calculating 30% more than 400 does not explain why quantities in a ratio must have the same unit. Therefore, option B is correct. Both assertion and reason are true, but the reason is not the correct explanation of the assertion. To summarize, the assertion about units in ratios is true as a fundamental mathematical principle. The reason about percentage calculation is also true, but is an unrelated mathematical fact. Therefore, option B is the correct answer.